In this video, I'm going to cover the A to Z of circular tracks, but in a very crisp and fast manner. Before I start, message, our live classes batch, the last batch for CAT 24 begins on 24th of June. So if you're very serious about this CAT and want a no-nonsense program where there's a lot of teaching of fundamentals and practice, then you can consider joining it. The description or the link to the course is in the description. And now let's get started. So our first learning objective is a very standard starting question. In this, the track length is given and the speeds are given. And we are talking about the first meeting, right? So the question is on a circular track of 1200 meter. Now this is the length of the track, that is the circumference, yeah, we'll denote it by L. A and B start running simultaneously. The standard situation is they start together and from the same point. So you just need to cursorily observe these things and their speeds are given, right? Now, if both run clockwise, so also absorb that which direction they are running, same or opposite, that is important. Here both are same. Then what is the least time after which B will cross A, right? And the time taken to cross is nothing but given by the track length over the relative speed, as straight as this. So this is your first relation that you learn from here. Right? Now if I just apply this, put these values, 1200 meters, speed is going to be 50 and they are running clockwise. So the relative speed is going to be this. We take the positive difference only, right? So that's 30 by 40, 30 will cancel this and I will get 40 seconds. So it is in 40 seconds that the B will cross A for the first time, as easy as that. Now this first crossing will occur at what distance from P measured clockwise. So now we are talking about where on the track is this meeting going to happen. And so for the distance, what you can do is you can choose, you can choose the slower one. Even the faster one will do, but slower will mean lesser work. You choose the slower of them, that is A. So you find the distance run by A. Distance is speed into time. The speed now we are taking only of A. I'm only focusing on A, 50 meters per second. The time that he has been running is whatever we found earlier, right? So he runs 2000 meters. Now this 2000 meters can be broken into, look at the track length, and it is 1200, that is one circle, and 800 more. And all of this is done in clockwise. So in how much distance is the point from P? The answer to that is this 800 meters further ahead from P in the clockwise direction. That 1200 gets flushed out into one round completely, right? So that is how you do it. If you take the speed of the faster one, you will still reach the same point because both of them are meeting together. I'll leave that work for you. Okay. Our second learning objective is, what if the data is given in a little twisted manner, right? So we got used to searching for the track length and speed, but that is not given. Instead of that, what is given is the time taken for one round is given. So this is what we'll learn next. So same question, A and B complete one full round in 10 and 15 minutes respectively. So instead of track, we have this now, and they start at the same time from the same point. Now this time A runs clockwise and B runs anti-clockwise. After how much time will they meet for the first time? So we go back to what we know. The time taken is the track length over relative speed. But this time we do not know the track length and the relative speed. Doesn't matter. You could start with a variable. So if the track length is X, the moment I assume the track length as X, from this data, I know that one round is X units, right? So whatever it is, meters, in 10 minutes. So this is distance, this is time, right? And that together will give me the speed. So what is the speed of the first guy? The speed of the first guy is, he covers X in 10 minutes. What is speed of the second guy? Second guy also, one full round is x meters in 15 minutes, right? So you x divided by 15. So it's just that we are in variables here, and this time they are running in opposite direction, clockwise and anti-clockwise, hence I will add it up. Now you see the x is immaterial here, it cancels out, and what we get here is, you could take the LCM of them, but let me use the numbers 10 and 15 themselves. So I'll take the denominator as 10 into 15, which goes into the numerator. Okay, and here I will be left with a 10 plus 15. Right? And then the x is immediate. This we can find out. 150 by 25. This is 6 seconds. So when do they meet for the first time? In 6 seconds. Done. So this relation, we could translate this relation also into TA into TB, okay, over TA plus or minus TB, depending upon the relative speed with the directions. If they're in same direction, do the plus. If they're in opposite, do the minus. But you should know this is coming from here itself, and you should know what TA and TB are. TA and TB are nothing but time taken for one round. Taken for one round. So we have a second relation also ready if the data is twisted. Again the same part, and where will this meeting take place? The distance. So our way to handle distance till now is we first find the time and then we go to the distance. As we get more insights, we can directly find the distance, but that is still some way away. Okay. However, in this case, we don't know any distance, right? X and so on. So measured clockwise, fine, from the starting point, but it will be expressed as a fraction of track length. So we go ahead now clockwise. Since it says clockwise, I'll have to take clockwise. A runs clockwise. So I'll have to find the distance of A. And what is the distance of A? One, I can use unimaginative way, speed into time. What is the speed? The speed of A we have found. A finishes in what? 10 minutes. So the speed of A is x by 10 seconds. Into time, how much? 6 seconds. So you could do this. This becomes, this will cancel out with a 2, 3x by 5. But now, 3x by 5 is the distance he runs. What is it as a fraction of the track? Fraction of the track. The fraction of the track is nothing but this thing by 5 divided by the track x, and x cancels and it becomes 3 by 5. Simple, straight, right? So this much fraction measured clockwise is the answer to this, right? So that is two very basic learning objectives done. And now we will see what is it that makes circular tracks tough and how do you unravel the mystery. Our third learning objective is that the first meeting, we have found the time taken for first meeting and also the distance, the point where the first meeting happens. And this first meeting is also same as a frequency of meeting. So circular tracks are tough because when people run on tracks, they meet, and if they continue running, they're going to again meet and then again. So there's a third, fourth, fifth, 8th meeting, 10th, 12th meeting, and that is what scares students off. And when we think in terms of distances, it's more troublesome because it's on the same track. On a timeline is linear, right? Now it is 10 minutes past, now 20, now 30, now 40, now 50, it will keep going. But on a track, the distance will get overlapping and that confuses more, right? So the way out for it is simply to understand this, right? So what I mean is there's an original start, and from the original start, we go to the first meeting. Now this first meeting is almost like a new start. And so whatever was happening here, as in the time and the distances run, both of it will again happen from here till the next meeting. So this is a new start. We can think of this as the first meeting after the new start. But yeah, after the new start. But if I look at it from the original start, it will be the second meet. Okay, and this will happen, the same thing will happen here. The same time it takes, the same distances they will run, and now this could again be thought as a new start. Okay, and from with respect to this, we are talking about the first meeting. So this is same as what we found will also be relevant in this interval. Okay, however, this meeting, if I look at it from the start, is going to be the third meeting. Hope you got the idea, right? So, very simple, students. Take the first meeting and now just keep these whichever way in your mind. Keep these ideas of repetition, or if you want more in maths, multiple. And this is what I'm going to show you next. So I've been a little fast. Now I'll become a little slow for this slide. So bear with it. We are taking the same first question, track length 1200, A, B, and both run clockwise. So we had found that the time in which they beat and 1200 by 30, 40 seconds. We found distance run by A was 2000, which was nothing but a full track plus 800, right? So if I now start plotting, so pay attention, this will be needed for the next slides, okay? So be very, very attentive. So we take a small track. So this was the original start. Let's talk of P, and both A and B were at this point and they were running clockwise. Now A here runs full 1200 and 800. Now this 800, how do I plot over here? The best way to plot is this 800 could be thought of as a fraction of the track. Okay, so 400 will cancel this, 2 by 3. 2/3 of the track. And the way to plot 2/3 is you divide the track into 3 equal segments. So this is a start and use this and 3 equal segments. So this. Right? Now he is going to run 1 full round and then 2 parts out of the 3. So this is where the first meeting happens. Right? First meeting. Now what we learned here is I can consider this first meeting at this point as a new start. Just name that point Q. Both A and B are at the same point and both are running clockwise. So this is same like this, except it's rotated. So from here onwards also everything will be same. So from here another 40 seconds, another this 1 full round and 2/3, and they will again meet. So how do you find 2/3 now? This is a point same as this. So if I divide it, I'm going to get the same points again. And 1 round, 1 part, 2 parts out of 3. So this is where the second meet happens. Keep paying attention, please, students. Yeah. Now if I start afresh again and I consider this as R. Now A is also over here, B is also over here. That is how they are meeting and they are running the clockwise direction. So this becomes like a fresh new start. Okay. After from here onwards another 40 seconds and another A running 1 round and 2/3, they will again meet. So the 2/3, this is same point as this. So the 2/3 will be same. Do you see I'm repeating the same thing? So 1 round, 1 part, 2 part, we are back to the original point. So this is where the third meeting happens. And this is exactly same as this. So after this point, we are back to here. Then this, then this, then this, then this, then this. And so the multiples will keep happening here. Is that okay? And the same thing happens in the opposite direction also. So we have the same. We have found the time. The time taken is 6 seconds or 6 minutes rather. Right? Because these are in minutes. 6 minutes, and then what? A runs clockwise. So when we talked about clockwise, distance run by A in fraction of a round is 3/5. Right? A is going to be faster this time, right? Why is A faster? Think he finishes a round in 10 minutes. Okay, whereas B takes 15 minutes. So it's okay, doesn't really matter too much. So if I take this circle, the original start, now we'll look at it from A's perspective. A is this side, B is this side, continue. How do I find the position? you divide the circle into 5 parts. Now 5 is odd, so the opposite one will not come. So take 2 points near the opposite, and then there is one more point. So you have divided into 5 equal parts. A will cover 3 out of the 5. 1, 2, 3. So A is reached this point. This is where the first meeting is. Now I would urge you to find the fraction of a round run by B. B in 6 minutes will run how much? You can even just take it's directly proportional. In 15 minutes, 1 round. So in 1 minute, 1 by 15. In 6 minutes, 6 by 15. Do that yourself, students, yeah, or else this video will get a little lengthy. And check that does B do 2/5 of a round? B will also be here. So this is the first point. And the point that we are stressing in this learning objective is that this point, if I name it Q, A has come here, A will continue clockwise, B is also here, B will continue anti-clockwise. So this is like an original start. So from here after, again 6 more minutes, again A running 3/5 of a round, they will meet again. So as explained that the points are going to be the same. Okay, so A will run 1 part, 2 part, 3. So this is your second meeting. And again, if I talk about this as my R point, new point. A has come here, but A is going to continue in the clockwise. B also has reached this point, but B will continue anti-clockwise. Same, exactly the same, students, right? So A will cover 3 points, 1, 2, 3. So this is where the third meeting happens. And let's continue. So this is where the third meeting happening. R, let's call it S. A clockwise, B anti-clockwise, same as a new start. So A will do 1, 2, 3. So this is where the fourth meeting happens, and continue. This is the fourth meeting place. Let's call it P. A will be here clockwise, B continuing, 5 points, and A will cover 1, 2, 3. And we are back to point P. So A is here and continue, B is here and continue, right? So this is back to point P. So one of the idea that people have is if they keep running on the tracks indefinitely, then they are going to meet at most points. Somewhere or the other, sometimes till infinite time, somewhere they'll meet, but it's not most points. There are very few positions that they meet, and then that repeats. So here, if they keep running indefinitely, they'll only meet at these 3 points. Here, they'll only meet at these 5 points. After this, they're going to go back here. Then second meet, then third meet at this point, fourth meet, fifth, sixth meet. What will be 6th, 7th, 8th, 9th, and then 10th again here, right? So hope you get that. So with this, this will form the backbone of our further understanding. So make sure you do this on your own, yeah, and don't just rely on watching the video. Assuming what was taught was perfectly clear, because that is going to form the foundation of what we are going to discuss next. Our learning agenda now shifts to the first meeting at the starting point itself. And there are 2 approaches to this. We are going to talk about the nth approach, the nth meeting. So the same 2 situations that we are dealing with since beginning. So the track length speeds are given, both run clockwise. Now the question is, after what least time will B cross A at the point P? So it is not just any meeting, it's not just the absolute first meeting, it's the first meeting at a particular position. Okay, the same thing is done with the second scenario that we have. Now, I'm going to directly use the, let's say, details we have seen on the previous slide. We saw that our first meeting was occurring at 2/3 of the track length. Then from here another 2/3, and from here another 2/3 is here. So this is what I mean by the nth meeting approach. The first meeting at start point. At start point is nothing but the third meeting from the third meeting. Okay, and if I know that the first meeting occurred after 40 seconds, then I know that the third meeting occurred after 40 into 3, 120 seconds. As straight as that, and that's my answer to this, 120 seconds. Should I worry about the distance? Not really. Why? Because the distance, the point is already known, right, in the question, right? So that's it, it's done. Now you might ask, how do I know this third meeting without having done that whole elaborate analysis? And the way to get to this is you take the ratio of the speeds. So in this case, the ratio of the speeds is 5:8. Okay, you have to take it in the most reduced form. If you don't do that, you'll go wrong. And because they are running in the same direction, therefore you take the difference in this, the positive difference, and that is the 3. And this tells me it is the third meeting. As simple as that. So the first time we know how to find out very fast, right? And then take it 3 times. Can I do that same for this question? Yes. So in this question, we have found the time taken for the first minute, which is 6 minutes. Okay, they are running in opposite direction, least time after which B crosses at the point P. So if I work this way, so we already know this, right? So for example, if I go back to the previous slide, originally we started from P. Our first meeting in A's direction was after 3/5 of a round. Now instead of going in different pictures, let's look here itself. First, then 1, 2, 3. This is where the second meeting happens. From here 1, 2, 3. This is where the third meeting happens. 1, 2, 3. This is where the fourth meeting happens. 1, 2, 3. This is where the fifth meeting happens, and fifth is at the starting point, right? Which is what we need to find for this question. So the answer, I hope you get it very clearly. It is the fifth meeting, and the fifth meeting is nothing but 6 minutes for first meeting into 5, the multiple. So the answer is after 30 minutes they meet for the first time at the start point, and here after 120 seconds. This fifth meeting, let's do this analysis here also. The speed of A to speed of B. Remember now, speed, data given is time taken for the same distance, and speeds are inversely proportional to time. So he takes less time, his speed is going to be more. So the ratio of the speeds is going to be 15:10. Make sure you take it in the reduced form, students. Yeah, do not skip this step. And from here, since they are running in opposite direction, therefore, what do? This time we will take the sum of these two numbers. So that is 5. And this 5 tells me it is the fifth meeting. The fifth meeting is going to happen at the start point, right? So which meeting? We found it using the ratio of speeds, right? We will stress this point again. But there are some more learnings about the meeting at the starting point. Okay, so keep a watch for that. So the next learning is the LCM way to the same answer. Okay, very interesting. Yeah, this has nothing to do with sort of circular tracks or so on. It's just LCM. So the same situation, same questions. This time we say, oh, when they meet at P, they're meeting at P. So you ask a question, when is A or B at point P? When is A or B at point P? This is your question. So if you look at A, so A is going to do one round in how much, right? He's going to, one round is 1200. Why one round? Because I want him to come back to P, right? Distance over his speed, only his speed. So this is going to be after 24 seconds. Right? And it's not just 24 seconds. A will be at P at 24 seconds, at 48 seconds, at 72 seconds, 96. So what are we talking? We are just talking about multiples of 24. Similarly, if you do this work for B, B will take one full round, 1200 at what speed? At 80. So that is going to be 15 seconds. And we know that B will be at start at point P at 15, 30, 45, 60 and so on. Now, if I want both of them to be at point P simultaneously, I look at a common multiple. And if I want the least, then I look at the least common multiple, which is the LCM. So what is the LCM of 24 and 15? So this is 24 and 15, and I guess you should be able to do it 120. So 120 seconds is the LCM. So let's check up, was this the answer when we did this? Yes, they meet it at P, the third meeting, which happens after 120 seconds. So we got the same thing here. Pretty simple, right? Now, here so I don't even need to find these time. Now this is given to me directly. So I just take the LCM of 10 and 15. A is going to be at the start after every 10, 20, 30, 40, 50. Rather at every means after every 10 minutes, that is at 10 minutes, 20 minutes, 30 minutes. B will be at 15 minutes, 30 minutes and so on, and 30 minutes is the LCM. So directly I could have got without any work, right? And that is what the answer we get here, 30 minutes. And so we'll continue. So this approach is also a good way, student. Directly you can hit upon the answer, and another way to look at it, right? And what is interesting in the LCM way is, these times that we have, are they really dependent whether A runs this way or A runs this way? Does it really matter which way? So what we realize is, this directions we never got into picture in this case. Now, what about directions? And that is our next learning objective. The first meeting at the starting point is independent of the direction of running. The first meeting, absolute first meeting, it could happen anywhere on the track, that is dependent upon which direction. But at the start point, that is not dependent, students, right? So we have already found, for this that the first meeting is the third meeting, which happens after 120 seconds when they run in same direction. Let me write this. In same direction when they run, we have found the answer as 120 seconds. Let's find for opposite direction. And if you do the LCM business, that doesn't need any direction. So we'll do the other approach, which is that approach, the nth meeting approach. Nth meeting approach, and see if they run in opposite direction, do I again get 120 seconds. So in the nth meeting, what do? I take the ratio of the speeds, and the ratio of the speeds is 5:8. But this time they are running in opposite direction, and therefore I will take the sum, which is 13. Oh, so I want the 13th meeting time. Do I know the first meeting time? This time is going to be, don't have a hangover, the directions have changed. The relative speed is going to be 50 plus 80, that is 130. Okay, so this is going to be 120 by 13. And so if this is the case, then the 13th meeting will happen after 120 by 13 into 13, which is 120 seconds again. So whether they run in the same direction, they meet after 120, in opposite direction, they meet after 120 seconds. So it is independent, right? Here we have seen for the case of that when they run in opposite, or rather I leave this case for you to do. This will be needed in the next slide. So when they run in the opposite direction, we know that we are talking about the fifth meeting, and the fifth meeting is the first meeting into 5, that is 30 seconds. After 30 seconds, they meet at the starting point. But what if they run in same direction? In same direction, the time taken for first will be 10 into 15, and now it is going to be 10 minus 15, but we'll take the positive difference, right? So this is nothing but 5. 150 by 5, that is 30 seconds. Okay, watch. 150 by 5 is a third. And if I take the ratio of the speeds, okay, we know that the ratio of the speeds is 3:2. Okay, but this time they are in same direction. So we take the difference, and the difference that we get is just 1. Notice this will be significant for the next slide. 1. Oh, so the first meeting itself, right? Let me write it as this, is at start point. So, and the first meeting was after 30 seconds. Itself is at the start point. So the meeting at the start point is 30 seconds. So something new has come up here, which I'll summarize in the next slide. But for now, whether they run in opposite or the same direction, the meeting at the start point is the same time because it is independent of running. And what we figured out here what we figured out is a small point, very small point. Can the first meeting at the start point also be the absolute first meeting? Pretty much that is what we saw. If both run in the same direction, the ratio of the speeds is nothing but 3:2, and since they are in same direction, they will only meet at one point, and that one point is nothing but the start point. Okay, so the first meeting will also be at the start point, the absolute first meeting, and that is the meeting at the starting point. In fact, if they keep running, there is only one point they will meet, right? So, but this cannot happen in the opposite direction. In opposite direction, if they start, they have to meet before reaching the start. But in the same direction, if the ratio of the speeds are 2 consecutive values, then the first meeting and the first meeting at the start point is the same. So on to further stuff. What if we have to find the meeting of 3 people? The question says ABC, track length of 1200 and the speeds are given. A is running clockwise, B and C are running anti-clockwise. After how much least time will all 3 of them be at the same point simultaneously? So he's talking be at the same point, but he's not specifying which point it is. So we are talking about the absolute first time that all 3 will be together. So the way is you find the time taken to meet for A and B, any pair. So for A and B, the track length is 1200 and their speeds are A and B, but they are running in opposite directions. So it is going to be the summation of this. So that is 80. 80 will cancel and I will be getting a 15. What are the units? Seconds. In 15 seconds, A and B are going to meet. What is significant is they are going to be together. A and B are together. Okay, not just after 15 seconds. And this is what I had talked to you about. Circular tracks being tough and that toughness being, how do you handle it? By taking multiples. So 15 seconds, 30 seconds, 45 seconds and so on. Let's find the time taken for any other pair. So I am choosing B and C. You can even choose A and C. And then the track length is this. B and C now are in same direction. So I will take the relative speed as a subtraction. So this is 40. 40 will make this 30 seconds. So B and C are together at 30, 60, 90 and so on. So now obviously we'll take the LCM of this. Okay, and in fact we can notice that 30. So what we have is at 30 seconds, or the LCM of this 2 type, A and B are together at a point, some point they are, when we say together we mean at this, and we also know that B and C are also together at some point, at a point. So the fact that B is common to the 2 pairs suggests that there aren't 2 different individuals, the same individual. He can be only at one point and he is at A also and he is at C also. Basically means that all 3 are at the time. So the way to handle for 3 people is take any 2 pairs, find the time taken, and the LCM of the time taken is going to be the answer there, right? Which pairs you could take? So you could take A and C and realize that whether you take these 2 or those 2 or all 3, the answer you'll always get the LCM is going to be 30. I leave that work for you. Also, if the data here is track length and speeds, if instead of this we had the twist in the data, the time taken for by each one for a round. I'm sure you can handle that now because you know how to find the time taken. And the second relation that we had, TA into TB over TA plus or minus TB would have given you this time, and then the LCM. Two more learning objective remains, and these are tough ones, so please pay attention. The uses of ratio of speeds, and there are two uses of it. First use we have already found it. To find the meeting number, that is which meeting is the meeting at the start point. So I'm not going to specify, spend much time here because we have done this. If the ratio of the speeds is A is to B in the most reduced form, okay, then if they are running in the same direction, then we take the difference of A and B, the positive difference. This TH meeting is at start point. Right? And if they are in opposite direction, rest everything, we just take the sum. So A plus B, this numbered meeting, this TH meeting is at the start point. We have used this also, so this is just a recap, right? And this is a new use of ratios. A misunderstood one, so we need complete attention. To find the positions, that is the points on the track where the athletes meet, if they keep running, how many distinct points on the track are where they could meet? And the idea is the same, students, again. So you find the ratio of their speeds in the reduced form, and if they are in the same direction, if they are running in the same direction, then we take the difference between them, the positive. These many points, these many distinct points are there on the track. Let me write it completely. Are there on the track where they can meet. Where they meet. If they are running in the opposite direction, everything is same. Instead of this, we take A plus B, and rest all remains same. These many points are there on the track where the athletes meet if they continue running, keep running. So these are the points where they will keep meeting, right? In fact, we have seen this earlier also, students. So I'll have to go back quite a bit. So remember that whole detailed understanding. So here is the ratio of the speeds. Nothing but 3:5, and they are in the same sorry, what is the ratio of the speeds? 5:8, and they are in the same direction, so we got 3. So these are the 3 points: first meeting, second meeting, third, fourth, fifth, sixth, and so on, and they'll follow a cycle. Here the ratio of the speeds we know was 3:2, right? And because they are in opposite direction, we will do 3 plus 2, 5, right? So remember this 5. These are the 5 points. That is how you divide. So let's go back to our learning. In fact, so we found the distinct points where they can meet. And how do we plot these? These distinct points is, they are all equispaced. And why are they equispaced? Because of that idea of multiple. Remember frequency, multiple of first meeting. If there is a certain distance that they travel and they meet, let's say 2/3 of a round, then from here onwards another 2/3, and from there another 2/3. That multiple makes them equispaced, and including the start point. Remember, the start point is one of the points. So you need a start somewhere to divide the track into so many parts. Okay, the start point is the one where you will begin, and the meeting at the start point is inevitable sometimes or the other. Why? Because any two numbers will have an LCM. Right, and that LCM is when both of them are at the start time, so they are going to meet over there. Right, now this is a misunderstood point, so let me do an example over here. So 4 athletes A, B, C, D running on a circular track from the same point, same time, same direction. Speeds are in the ratio 1, 2, 3, 4. Find the number of points on the track where any two of the 4 athletes can meet. It's a standard question which is asked as doubt by quite a few people. It should be covered in any good study material, students, right? So any two, so we take them pairwise, students. So if I take A and B, the ratio of their speeds is 1:2, and because they are in the same direction, 1 point, they are going to meet only at 1 point, and this is going to be the start point. That's it. So A and B, if they keep running, there's the only point where they'll meet is the start point. If I take pairwise, so I'll continue with A. I'll not go A, B, B, C, C, D. I'll continue with A, exhaust 1 and 3. So this is the difference is 2 points. So they are going to meet at 2 points. So here 1 is the start point. Okay, and the opposite, diametrically opposite, the half. So I'll plot it down later on. I'm just writing here opposite. So that is 2 halves. And if I take A and D, the ratio of the speed is 1:4. So they will meet at 3 points. I'll explain the 3 points after some time. Okay, the A is exhausted. So I'll start with BC. BC, the ratio is 2:3. So BC will also meet at only 1 point. That is the start. B and D. Now watch here, student. If you take B and D as 2:4, you will go wrong, students. This reduced form is 1:2. So B and D is also going to meet at only 1 point. And last pair, which is C and D, the ratio is 3:4. They will also meet at 1 point. Now obviously you can't add these points 1, 3, 3, 6, 7, 8, 9, right? Again 9 will go wrong, students. Okay, 9 is not. There are a lot of common points here, right? So all of them have the start point. All of them have that. So you would have to sort of take the track. This is the original start point. This is anywhere where there's a 1. This is done. This is done. This is done. This is done. All these points refer to that. 2 points. These 2 points, one of them is this and the other is here. So these 2 points are also done. And these 3 points, one of them is the same thing and the other is here. You divide it into 3 equispaced points, right? So if you look over here, there are only 4 points at which any two of the athletes will meet. Clear? No problems, right? So hopefully things have got cleared here. So let's see what's the next on agenda. So we have a, before we move to the 7th one, there's this common error of mistaking the points of meeting as number of meetings. A lot of people make this error, right? Somehow they feel that this is a lot of insight. You know this, wow, I know where all they can meet. Oh, they can meet 4 times. They can meet the 8 times. No, it is not number of meetings. It is the number of points where they can meet. So, if I give you a half-baked question, in a race, I have skipped something. The ratio of speeds is 3:5. And if they run in the same direction, how many times do they meet in the entire ratio? For some reason, people take this and they will say, oh, it's the same direction, so therefore take the difference. The difference is 2, so they will meet 2 meetings. No, this is wrong. Okay, this is wrong, students. How can you say 2 meetings? The meetings depends on the race, no? The meeting and so on, number of meetings, if they keep running, they can keep meeting. What is this 2? This 2 is there are only 2 points, the original start and the opposite. These are the 2 places where they can meet. So let's say they start from here, A and B, okay? And remember, the first meeting cannot be here, because if the first meeting happened here, then the second would also be here, third will also be here, fourth will also be here, then this point is not a meeting point. But we know that there are two distinct points. So the first meeting has to happen here, the second meeting will happen here, the third meeting will happen here, the fourth meeting will happen here, the fifth meeting will happen here, the sixth will happen, and so on. So remember, the number of meetings could be lot, 6, 7, 8, 9 in the same 2 points. So don't confuse the 2 points as the number of meetings. Then how do we find the number of meetings? That is our last agenda. 2 ways to find the number of meeting. The first one is the frequency approach. And this is a simple approach where, if I say bells, a bell tolls, rings, tolls every 10 minutes. Right? And then I ask you how many times. This is the how many times a meeting happens. How many times does it toll? So I'm pretty sure your reaction is going to be a very common reaction. Yet after 10 minutes it happens, then another 10 minutes, and then another 10 minutes. Then how many times does it toll? So your expected reaction is in what interval? In what duration? Right? This is what I was trying to tell you even in the last slide when I was talking about second, third, fourth, fifth, sixth, seventh, eighth, ninth. How many meetings? In what? When? So in the race, that kind of a thing. So in what duration? So, and the number of times that it will toll is nothing but, let me just call it the duration. Okay, a given duration over this frequency. I'll call this as a frequency. So if you're asking me over 1 hour in 60 minutes, so if you're talking about 60 minutes, okay, and then it happens every 10 minutes, right, then the answer is going to be 6, and the units for this is going to be times, 6 times. The first time is not being counted, the last time is being counted. Is that okay? That's a very standard way, right? So this is the approach. So duration over frequency. And do we know the frequency? Yes, the frequency of meeting, we found it. That was the time taken for the first meeting. So your question, in a race of 4,800 meters, so there's a race of 4,800 meters run on a track of 400 meters. So we are getting into tougher things now. Oh, there's a distance here and the track is 400. So don't get misled. What is the track length? The track length is 400, students. Okay, then what is this? Oh, they'll keep repeating, okay, like laps. So 400, 400, 400. You should have thought in your mind 12 laps they will do. The ratio of the speeds is 3:5. So directly the ratio is given. I don't know exact numbers. If they run in same direction, how many times do they meet in the race? So my first thought is going to be frequency of meeting. That is how we started the first learning agenda. Time taken to meet, track length mind you, okay, over relative speed. Oh, the relative speed is 5x minus 3x, or if you prefer a k, 5k minus 3k. That is a 2k, so 200 by k. So we don't know the actual speed, so we cannot find the actual time, but we have got it in terms of k. And then what is the duration of race? So where is it? In how many times will they meet in the entire race? So how long is the race? Duration is also a measure of time. So what is that time? So what is the race duration? Race time. So let me call it the race time is, in the race, the distance to be covered is 4,800 meters. Time is 4 by speed. Whose speed? Is it the relative speed now? No. The faster one is going to finish the race. So the faster one is going to go ahead, the slower one is lagging behind, right? And that is circular, so they'll keep meeting, but the faster one will reach the race end or will finish and will get off the track. Then the slower one will keep continuing, but no meeting is happening after that. So the faster one is 5k. Okay, this is meters per second, let's assume, right? So this 5 will cancel this, and this will become a 960 by k. And using the frequency approach, the number of meetings is nothing but the duration, the entire window. You could even think of this as window of opportunity, the window during which they can keep meeting, and they keep meeting after how much? After every 200 by k. So the kk cancels out and you are left with a 4.8. Now obviously they can't meet 4.8 times, right? So this means 4 meetings are done. 4 meetings are done. Okay, but they are almost close to the 5th meeting, right? But the 5th meeting has yet to happen, right? So that is the idea here, right? And if you look at it, the ratio here, same direction, there are just 2 points. So in 2 points, but the number of meetings is 4. Now the next approach, students, for number of meetings is a very insightful one. The sum and difference of rounds run. Probably I'm not going to use it sometimes. This is good enough and it's not time consuming, but this is so exciting, or so let's say it puts a finishing touch on our understanding. So I think you should do it, okay? And it will require a lot of attention from you. The sum or the difference of rounds run. Okay, so we are back to our starting 2 scenarios. Okay, and now 1200, 50, 80, you know. So we are going to now talk about the meeting number. Okay, and you know the time taken is going to be, the time taken for the first meeting is going to be same direction, 30, 40 seconds. Okay, and you also know that the distance run by A. Distance run by A is you can even do it 40 into this, that is 2000. Okay, so I'll do it here. Meeting, and we are now focusing on the rounds run, students. Okay, so let me call it rounds run by A, rounds run by B. So A has covered 2000. 2000 when I divide it by the track length, okay, I will be getting 5 by 3. Okay, you can even think of it as a mixed fraction, 1 round and 2/3 of a round. This is the first meeting. And what about B running at that time? B has run 80 into 40, 3200 meters. If I talk of rounds run, I'll divide it by the track length. So in fractions, 4, 8 by 3. And as mixed fraction, 3 2s are 6, 2/3. Okay, so now the second meeting is a multiple of this. So I'll do fast. So I'll not go to here. I'll just do this as 10 by 3. And 10 by 3 is 3 rounds, 1/3 of a round. This is going to be twice of this, 16 by 3. This is 3 5s are 15 and 1/3. And look here, he's 1/3 of a round, he's also 1/3 of a round. So they have met at that point. He's 2/3, he's 2/3 of a round. They have met that point. And the third meeting, you remember, is the start. So if I multiply the first by 3, he has run 5 full rounds. Okay, so that's just 5. And he has run into 3 8 full rounds. So that's this. Now, because they are in the same direction, take the difference in the rounds run. And what is the difference here? 2 2/3 minus 1 1/3 is 1 round. What is the difference here? 5 minus 3 is 2 rounds. What is the difference here? 3 rounds. So the difference in round run is same as the meeting number. Right? And it's very classical way, students. Yeah, the moment the run starts, has the faster one taken a lead? And Lead right now is a minute fraction of the whole track length. Both are running, both are being displaced, but that just focus on the lead. The lead keeps getting increased. It becomes quarter of a round, then it becomes half of a round. Now in half of a round, they are diametrically opposite, but where are they? We don't know, but they are diametrically opposite. And then it becomes 3/4 of a round, then it becomes 9/10 of a round. 9/10 of a round seems that the faster one is behind the slower one, but he is 9/10 of a round ahead. So he's going to catch him up, and he'll catch up only when the difference of round is 1. And the difference of round 1 may happen when both have run 8 and 9 rounds, might happen when both have run 24 and 25 rounds, if the ratio of speeds is 24:25. Right? You don't know how many rounds they have run. We are looking at the difference. Anyway, so I don't want to get into detail. If you got the hang and feel of it, this is again obvious. Why? The moment one round difference is done, you're back to that multiple. Both are together. Hereafter, the story starts again. Now he'll have to chase one full round more. So one round already he was ahead, one full round ahead, that's 2 rounds ahead for the second meeting, 3 rounds ahead for the third meeting. Ahead means difference. How logical that is, right? Let's do it out over here. So we have meeting number, rounds and rounds run by A, rounds run by B, and obviously you can anticipate, since they are in opposite direction, we are going to now talk about the sum of rounds run. So it's just left for us to see, observe, right? So the first meeting we know happens in 6 minutes. Right, 10 into 15 over 10 minus 15, 6 minutes, and we know in 6 minutes he does 6 by 10, that is 3/5 of a round. Okay, B does 2/5 of a round. Okay, the second, so 2i 6 by 5, that is nothing but 1/5 of a round. 4 by 5 of a round. Now are they at the same point? He is 1 round 1/5. He is 4/5. They are not at the same round, but think ahead, think a little more deeper. Okay, the third meeting, multiply this by 3. 3 3s are 9 by 5. 9 by 5 is 1. 4 by 5. Okay, multiply this with a 3. 6 by 5 is 1. And what else? 1 by 5. Fourth meeting into 4, 12 by 5. That is 2. 2 by 5. And into 4, 8 by 5. 8 by 5 is 1, 3 by 5. And the fifth meeting is into 5, 3 rounds. Into 5, 2 rounds. Now let's take the sum of rounds. So if you take the sum of rounds, you get 1 round. If you take the sum of rounds, this is 1, and these two fractions add up to 1, 2 rounds. Here 1 round plus 1 round, and these fractions add up to the third round. 2 and 1, 3, and these fractions 4, and this 5. Do they correspond to the meeting number directly? Right? So it's easier in the opposite. They start and they remember the sum of rounds has to be 1. The right hand and the left hand together is completing a circle. And if you get it once, you have to just tell the same thing happens second time. The same thing happens third time. For every meeting, the sum is 1. So 1, and the next meeting again 1 more, that is 2 from the start, again 1 more, 3 from the start. And how do you handle this to answer the question? Same question we have for race, right? Now we know the ratio of speeds, and you also know that this means the race is of how much? The race is of 12 rounds. Whoever does 12 rounds first. Now who is going to do the 12 rounds, students? The 12 rounds is going to be done by the faster one. So the rounds run or distance run is going to be proportional to the speeds, because the timer, it's a race, both are running for same duration, time, right? So, okay, so this 5K, the 5K is equal to 12 rounds. So the question is 3K is equal to how many rounds? And K is 12 by 5. So 3K is 3 into 12 by 5. That is 36 by 5. 36 by 5 is 7.2 rounds. So if you know the rounds that the individuals have done, because they are in the same direction, could you take the difference of rounds run? And the difference of rounds run is nothing but 4.8 rounds. So has this guy run 4.8 rounds more than the slower one? So which means that they have already met 4 times, 4 meetings, and the 5th meeting is about to happen but not yet done. So have we come to this as well? So this concludes all our learning agendas. Objectives, you could rewind it and you should be able to rattle off all the objectives. Time taken for first meeting, time taken when time for a round is given. The first meeting is nothing but the frequency of meeting. The first meeting at start point, there are sub learning objectives over there. That is how you revise, right? The 5th one is going to be the uses of ratio speed. The 6th one is distinct points where they can meet. The 7th one is the number of meetings, right? That in short. But that doesn't finish it, student. There can be many non-standard questions, right? Like they are positioned diametrically opposite. Okay, track length is given 800 meter, but both start running in clockwise and A catches. Oh, the time taken for first minute is given. We don't know the speeds or so on. So that could be something different. In fact, they're asking us find the number of times they are diametrically opposite. There can be huge number of questions of a different type, but that is something that, you know, after you build a base, you try to handle it. So this was just about the base. So I want to end it up by just reminding you, if you want a batch where things are taught in such a comprehensive way, you can consider this. The link is in the description. Thank you.